Hi, I'm Doug Coughlin from Buildbotics. I've recently taken on a project, actually on my own, to create a 5-axis CNC machine using a Buildbotics controller. And in doing that, I've had to build a few special parts to make the whole thing work. For instance, I had to make these two work table plates to attach to this 2-axis rotary unit that I purchased online. And in making these plates, I realized that if you have to cut through a lot of aluminum, 6061 aluminum, using basically my home-built CNC machine, which is pictured right here, you're best off using trochoidal milling. And trochoidal milling allows you to take deep cuts in aluminum in a series of circular sweeps. So I've created this video that, after I had these built, I decided to make a video showing trochoidal milling and point out some of the trials and tribulations I went through to get it working. So here goes. So I created this test cut in G-code and then simulated it in Buildbotics, and here's the cut path as shown in Buildbotics. It's interesting, it's a lot of cutting, but it's only 47 lines of G-code, including spaces and commas. Since trochoidal cutting uses consistent smooth forces and a very small depth of cut for each swipe, you can use a fairly high feed rate. The feed rate on this cut is 2 meters per minute, and the speed of the spindle is 15,000 RPM. This particular cut makes a 20 millimeter wide slot through the 6061 aluminum, which is 12 millimeters deep. In order to make this slot, it needs to make circles that account for the width of the bit as well, and so the radius of the circle is only about 6.8 millimeters. Maintaining velocity of 2 meters per minute on circles with a radius of 6.8 millimeters drives up the junction acceleration. The junction acceleration that can be adjusted on the controller is entirely dependent on the mechanics of your machine. My machine has a fairly large gantry that weighs over 100 pounds, so it has to be able to account for the weight and the forces, plus the force of cutting as it's going around these circles. There are 4 parameters that you should consider when tuning your Buildbotics controller for the maximum junction acceleration. These are max accel and max jerk on the motor settings page, and max deviation and junction acceleration on the settings general page. The maximum junction acceleration that your machine will tolerate can be determined through trial and error. If your cut exceeds its ability to accelerate around a junction, then you'll lose steps, and you can hear that. I had to adjust the junction acceleration on my Buildbotics controller from the default, which is 200,000 millimeters per minute squared, up to 800,000 millimeters per minute squared. I also adjusted the max deviation on the same settings page on the Buildbotics controller. I adjusted it from 0.1 millimeters to 0.2 millimeters. This allows the machine to deviate slightly from the path and round out the curves a little bit, reducing the acceleration around the junction. Finally, I set my max accel on the X and Y axes to 10 kilometers per minute squared, and the max jerk to 2,000 kilometers per minute cubed. Thanks for watching, and don't forget to check us out at Buildbotics.com. As always, likes and shares are greatly appreciated.